Hello everybody, welcome back. Today is another video as part of a video series for Trigonometry and Algebra 2. This is the problem where we need to determine this angle, which is expressed in radians right now, into degree, right? So this is like a very common problem in trig reasons. Based on my research for almost 10 or 11 different reasons exam, I would say you will get 6 or 4, at least 4 points worth of problem, either one problem or two problem in multiple choice and one problem in short response for points worth 2 points. So it's worth exploring this concept and understand what it is and how do we do this, not only solving this particular problem but in general as of understanding, so you'll be able to solve problem like this in future. So let's do that. Let me draw a circle. I have this circle and that's not a circle, is it? Okay. Let me draw a circle. Perfect. Okay, so I have this, this is the angle theta. Okay, and that is what we are looking all the time. So we'll find some angle in a circle, and there are two ways of expressing it, either in degrees or either in radians, right? Okay, so the maximum degrees that is allowed, the maximum number of degrees that is allowed in a circle is 360 degrees, and that 360 degrees is worth 2 pi in radians. So basically this is how it works. Right, okay. So 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then when you come back here, 2 pi. So it's going this way, right? So so in terms of degrees, it would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then you come back here 360 degrees, right? And then there may be another angles like 51 degrees and all that. That is when we need to use this concept to find out what it is in terms of degree or in terms of radians. So let's say you're converting, you're going from let's say D for degree, right? And then R for radians. So you're going from degree to radians. So what do we do now? Let's say I have 30 degrees, right? And I want to convert it into radians. What do I do now? I would multiply with pi over 180. So if you introduce that pi on the top and divide it with 180 and multiply that whole thing with whatever that number in degree is, you'll essentially convert this into radians. So let's go and compute it further. 30 times pi over 180 is, guess what, 1. So how many 30s that goes into 30? 1. How many 30s that goes into 180? 6, right? So it's pi over 6. So 30 degrees can also be expressed as pi over 6, and they both retain same value. It's the same thing but different format of expressing that angle, right? So okay, this is going from degree to radians. Now going from radians to degree. Okay, let's choose a radians number. Let's choose some random numbers, easily computable. So let me use pi, or let me erase that, sorry about that. Let me say I'm going to do, let's say pi over 3, right? I'm converting pi over 3 into degree. What do I do now? You noticed what we did was we multiplied pi over 180 when we were going to radians. When we are going to degree, we're going to do exact opposite. We're going to multiply with 180 divided by pi. And there is a trick behind it. Why are we doing it? Because this was degree, this was degree. You want to get rid of that degree unit. That is why you divided with 180, right? So here you want to get rid of this pi radians unit, so you divide with pi, so you will only have degree left. That is the whole concept. So pi over 3 times 180 over pi. I'm just rewriting it because all that markings. So this pi, that pi cancels because it's multiplying a fraction. And numerator, denominator, they cancels each other out. Same thing. How many 3's that are in 3? That is in 3, 1, right? Okay, same thing. How many 3's that is in 180? Okay, if that is too hard to compute, since this is 180, easy numbers, just think of 18. There are 6 3 in 18, isn't it? But then that 0 just follows, so the answer is 60. So your answer would be 60 degrees, right? So pi over 3 is 60 degree. So what we did was converted from degree to radians, converted from radians to degree, and you can pretty much choose any numbers. I chose easy numbers, you know, so it's easily computable. But instead of using 30 degrees, you can also choose, you know, 30.1 degrees. It doesn't matter. It's the same thing. What do we do now? Pi over 180. You will get 31 pi over 180, and basically use your calculator section and calculator to find this part, and that will be your answer, right? Instead of pi over 3, you can use, let's say, you know what, let's go crazy, 7 pi over 11. Okay, so that 11 looks like pi, isn't it? So let me erase that. Okay, so that pi cancels, and then basically you have 7 times 180 and 11, and whatever that is after you do computation on your calculator, that'll be your answer, but it's in degree, right? Whatever that is. So that is how you convert from degree to radians and from radians to degree. Okay, so once now you're equipped with all these ideas, I think you can go ahead and solve this. So let's start. We have 8 pi over 9, and then we need to convert it into a degree. So what do we do now? Since we are going from radians to degree, we're using this. So 180 over pi. Okay, and just to quick check, you're going from radians to degree, and you do pi over 180. Just a mistake. It can happen anytime, right? But then you notice pi same side. It can't be true because you're not gonna get rid of it. You're gonna get pi square. So if you get pi square, that is wrong. So subtract this, erase this. Let's not do that, and you'll get pi cancels out. There are 9, there are 29, and then you have 8 times 20. That is 160 degrees. And I just converted 8 pi over 9 into degree, which is 160 degrees. I mean, after you know all this, what we did before, which is right here, doing this would be like what, 6 seconds thing, right? But you need to know the concept behind it, and that is the concept that you need to know to solve any problems related to degree or radians. Thank you for watching. Please do not forget to subscribe my channel for more videos to come.